you to another multivariate statistics class. Four of us want to appreciate those that attended my talk on Wednesday. I think I had a fantastic talk, and I really appreciate your attendance. So today we actually going to complete the chapter that we started this week. Um, you know, I call this miscellaneous topics in data matrix. Earlier in the week, I introduced you to data matrix. Of course, I will walk you through some definition, properties, and how to implement that in R. Then I remember we also did covariance matrix. And of course, on Wednesday, I walk you through correlation matrix. I gave definition, properties, and how that can be implemented in R. But today, the focus is going to be on vectors because it's miscellaneous topics that we want to talk about is vectors. And let me tell you this, we actually, you've seen matrices, you've seen vectors, but at times maybe initially we have matrices, and because of one or two reasons, we convert matrices into vectors. Okay, so our four of us give you what are the significance, like what do we stand to benefit, converting matrices to vectors, because we don't just do what we do. We got uh, you know, reason why we do what we do. I'm actually going to walk you through that today. Now, I want to start with cross products before going into vector. In statistical analysis, we've come across stuff like this so many times. And cross products it has to do with I have a matrix and I have another matrix, and maybe I'm multiplying the matrix by the transpose of the other one. I'm actually going to say um, this particular cross product can be found in covariance. If you look at the formula for covariance, okay, the cross product is taking place. Cross product also provide a foundation for estimation in regression analysis. I'm going to write a formula if you want to figure out um, if you have a model, maybe you are looking at the effect of, let me see, uh, maybe you are considering factors that determine wages. And in your model, the explanatory variable include the numbers of years of education of the workers, and also include numbers of years of experience, among other explanatory variables. Okay, if you look at what happened behind the scene, you have a model Y. Okay, um, a second. So you have a model Y equal the specification of the model in matrix form is actually this plus the error. Okay, this is in matrix form. Y is a matrix, X is a matrix, the beta is a matrix, the beta is the regression parameters that also include the intercept. Now, if I actually want to have a parameter estimation, of course, um, the formula that was programmed behind the scene is S prime S inverse, the inverse X prime, S prime Y. Okay, X prime Y. Now, if you take a look at this, is a cross product that we're talking about, the S prime Y that we're talking about. So without a cross product, there is no way we'll be able to estimate parameter in a linear regression model. If there's no way you can do that, then there's no way you can actually measure relationship between the response and the explanatory variables. That's what we mean. So the cross product is very, very crucial, okay, in statistical analysis. Not only in statistical analysis, okay, the cross product that we're talking about, okay, without cross product, you may not be able to have a covariance structure. You may not be able to understand the covariance structure of your matrix. Without cross product, there is possibility you may not be able to perform what I call data reduction technique. Okay, statistics is what make statistics more beautiful. It's mathematics. If you have issue with mathematics, you will have issue with statistics. At times, you need mathematical knowledge to understand statistics, probably at master's or PhD level. Now, we don't just do what we do. There's a reason. So by cross product, this is what we mean. Now, how do we implement this in R? It's actually here. I have a matrix X. Okay, I got a matrix X. Okay, I'm actually simulating that very code means I'm simulating from normal distribution. You can see R norm using R. I want to simulate that particular matrix. I want to simulate the data. Okay. I also simulate Y. You see Y? And of course, I want to perform a cross product. Okay. You know, this is transpose of S, T of S, transpose of S multiply by Y, and which is actually going to give this. That's a cross product. Another way you can do that in R, if you don't want to program like that, like if you don't want to program the transpose of X, multiply by Y, you can just write cross prod. Take a look at this. The moment you have your X and Y defined, you can just write a cross prod X comma Y. It's going to give you the cross product you're talking about. Okay. And of course, you can also go the way of this one. Okay. And you can go the way of that for that one. So this is a different one. You take a look at what I'm doing here. Okay, is X uh multiplied by Y transpose this time around. The first one I did, if you take a look at this one is X transpose Y. Okay, but this one, okay, X Y transpose. Does that make sense? The two of them are cross products. I think I just gave you the significance. I just gave the significance of that. You know, when you are doing maths, if you know how to do maths, you know how to differentiate, you know how to do algebra, you know all of that, but you don't know the reason why you are doing it. It doesn't make sense. Everything in life that exists There's a reason for existence of anything. Okay? And that is why you need to be able to ask questions most of the time. What is the essence of what I'm doing? Because you don't want to waste your time. Okay, I think I've shown you how to implement that in now. Now, this is where we're going. Turning a matrix into a vector. We know how to do the math, but what is the essence? I'm going to tell you the essence now. Okay? The number one reason why I want to turn matrix into a vector, okay? There's so many reasons, but one of the reasons, when you are seeking optimization, particularly you have a multivariate calculus, okay? Multivariate calculus, okay? Multivariate calculus is better achieved with vector. Has anybody done multivariate calculus before? Okay. Did you confirm what I just said? Like in a vector form, right? Okay. So it's better done, in vector than in matrix. I'm talking about multivariate calculus, or you are into optimization where you are using the idea of a gradient function. Of course, the idea of vector is actually gonna work in that regard. There's so many benefit that we can actually have, from converting matrix into a vector. you know it enhances computational efficiency, particularly when you are working with a large scale problem. When you're working with large scale problem, working with vector instead of matrix guarantee, it will lead to enhanced efficiency. Okay. So, and we normally observe that in machine learning. Machine learning is about big data. Big data, induces complexity in terms of, if you want to figure it out, of course, we normally convert matrices to vector. It's not as if we can work with matrices, but working with vector will increase efficiency. Does that make sense? Okay, so I've mentioned matrix calculus, multivariate calculus, and also going to say even in dimensionality reduction, okay, or feature extraction, we have so many features, okay, and you actually want to select most relevant features. Working with vector will make more sense, compared to working with matrices. Okay, I think I've given a lot of yeah, there's particular one I'm going to mention. Has anybody heard about tensor operation and deep learning? Deep learning. Okay. So, working with vector in that, actually we ensure that we have that operation done effectively. Well, let me tell you this. Converting a matrix to vector, you're actually going to use what I call transpose. Transpose is very crucial. If you take a look at what I have right now, vector x, I have x is a matrix itself, and I want to vectorize a matrix, and this is what I have. Okay, that's what I have. If you want to try, make sure you always try my code, the R code, but you can't do multivariate analysis without using the software. Okay, so if you take a look at this now, this particular haro code explain how to vectorize a matrix. Okay, I have a matrix. Okay, I have 1 to 6 numbers, 1 to 6, and I want them in 2 by 3. Okay, if I want them in 2 by 3, I first create a matrix. This is a matrix of 2 by 3. Okay, and of course, or when you look at the column of that, it's 1, 2, 3, 4, 5, 6, which is what you see in here. Okay. So that is more or less like I'm trying to vectorize that, vectorizing a matrix. And vectorizing, the vectorization is actually done column by column. Okay. Okay. Now, when you talk about, you remember the other time when we were dealing with the matrices, we talk about properties associated with matrices. But right now, we also want to talk about properties of vectors. Okay. So, and so these are the properties that of vectors that we can verify. Okay. But there's a particular notation that is very, very crucial. Okay. But let me start with the property number one. It's talking about vector. If I have matrix, if I have a matrix A, and I find the transpose of that, of A, so the vector of one is equal to the vector of the other. That can be verified. Or I have A multiplied by the transpose of B, and I want to vectorize. The vectorization will lead to what I call chronicle products. I need you to pay attention to this guy. That's a chronicle product. Whenever you see this sign, okay, that's a chronicle product. The way matrix multiplication is done is different from the way vector multiplication is done, like chronicle product is done. I just wanted to take note of that. Okay, this is what it's trying to say. Okay, but all these have already been mathematically proved and statistically observed to be correct. Okay, so moving away from that, okay, we can begin to look at two matrices. Oh, sorry, two matrices. And on the two matrices, I want to have a chronicle product. Okay, I want to have a chronicle product. The first matrix is N by P. The second matrix is M by Q. But there's something I wanted to see. The dimension of the matrix if I want to treat this as matrices, the way it's going to be done is different from the way we are actually doing it right now. Okay, I'm going to say that again. The way it's going to be done is different from the way we're doing it right now. Okay, of course, if it were to be matrices, of course, before they're going to be conformable for multiplication, the number of columns in the first one must be equal to the number of rows in the other one. And of course, we can determine the dimension of the new matrix. But right now, this is different. I wanted to see that Y, matrix Y itself, multiply every element in matrix X. Look at that. Do you see what I'm saying? That Y is a matrix itself. If I'm actually referring to this particular Y here. Okay, take a look at this Y that appears in all. Look at that Y. Can you see that Y? You're using it to multiply each element in matrix S. And don't forget the Y we're using is a matrix of M by Q. Okay, this is what we call, okay, a chronicle product. And the dimension of a chronicle product is what I'm going to show you now. The dimension is this. Why? Because Mn is dimension of matrix X, PQ, okay? So this is what I mean. You're going to see now. The dimension of matrix S, N and P. The dimension of matrix Y is M and Q. Okay, but the dimension of the new matrix, you're actually going to see of the new the matrix that we have. Okay, look at this. Mn PQ, which is this one. Okay, I wanted to take notes of that. Is there any question? Is there any question? Okay, so if there's no question, of course, I'm actually going to continue. Now, how do you do it now? Like I said, you got nothing to worry about. That's why, I always going to put an arrow code for you to run yourself. Make sure you always practice the arrow code. Now, I want to generate a matrix X and Y, and I want to perform chronicle products. I want to perform a chronicle product. Okay. Now, performing a chronicle product, you know, the chronicle itself is inbuilt in R. So if the moment I have my matrix X and Y, I'm just going to write chronicle. Can you see that? X comma Y. Okay. You see that? You see this guy here? You see this guy here? Okay. Chronicle X comma Y. Okay. And that is going to give you, the results. Okay. With the software, everything is easy. The one thing is for you to be able to, you need to understand the right code. Okay. Different kind of software can be used. They're all going to get the same result. They only have different codings, but the same result. Why the same result? Is because the same formula is programmed behind the scene. Does that make sense? Okay, we can investigate some properties of a chronicle product. Okay, we can investigate all those properties. That can be investigated using R. Can investigate that using R. Okay, so what I want you to understand, how am I going to recognize a chronicle product? Okay, don't forget the sign. Okay, this sign, you see that sign? That's a chronicle where you have a cycle and it's a cross on the cycle. That's a chronicle. If it is just, if you see something like this, please pay attention. If you see something like this, okay, then that is not a chronicle product. That's just the product of two matrices. Does that make sense? But if I now put a circle over S, oh my God, that is no longer a matrix multiplication, but that's a chronicle product they expect from you. Okay, so is there any question on that? Okay, so the other time I think I've already given you the significance of having this kind of product that we're talking about. Okay, like I said, you can investigate all of that, but I'm gonna move right now. Now, I need you to pay attention where we are now. You need to pay attention. Now, common application of vec, and I say vec, I mean the vector that we're talking about, and chronicle. Okay, why are we doing the math? Why are we going to chronicle product? Why are we going to cross product? We have a reason for doing that. We now want to talk about the application. We don't do what we do. We got a reason why we do what we do. And I need you to pay attention to application, how this is applicable in multivariate analysis. We normally go from math to statistics. Okay, anybody have issue with stats? That person have issue with math. That is my understanding. Now, let's get started. Suppose the role of S are IID samples. IID means identically and independently distributed. They're identical because they are from the same distribution, okay? And they are independent. That's IID. Okay, sample from some multivariate distribution Of course, our next topic, our next chapter, next week, we are starting multivariate normal distribution. Okay, from multivariate distribution with the mean, let me tell you this. We have a univariate distribution, we have a bivariate distribution, and we have a multivariate. For instance, if I'm talking about normal distribution, okay, you're talking about normal distribution. I have a random variable x, follow normal distribution with this, okay, f of s equal 1 over square root of 2 pi sigma squared, exponential raised to the power that x minus mu over sigma squared that x line between negative infinity to infinity. What am I talking about? I'm actually referring to this, a double bell shape. Okay, in a stochastic environment, if I actually want to understand the random variable, I need to be able to understand how it is distributed, the probability distribution of random variable matter in a statistical world. Now, some data set may follow normal distribution. Some may not follow normal distribution. Why do I care about whether they follow normal distribution or not? Is because we got some approach in statistics. We got some techniques that operate under assumptions of normality. We got some technique that operate under assumptions of maybe there's a deviation from normality. Now, in statistics, what we do, because we actually want to depict to reality, we actually using a model to depict to reality, and we actually going to use our model on our data set. The state of the model and the state of the data must agree. If the state of the model and the state of the data don't agree, then you are never going to have information that you are looking for in data. And that is why the distribution of random variable is very, very important. Now, univariate in the sense that here, this is I'm only considering just one measurement, one totally talking about one particular variable, maybe blood pressure. If I'm talking about blood pressure, okay, the distribution of the blood pressure of my patient followed normal with the mean of this, with the variance of this, and this is the probability density function. But right now, I'm a doctor. I'm a doctor now. Okay, I'm a physician now. I'm not interested in just one variable. I'm interested in so many variables. Maybe I want to talk about the height, the weight, the blood pressure. Then those variables, we call them multivariate. Okay, not just one variable, and they all follow normal distribution. If they all follow normal distribution, instead of me to have this guy, I'm not going to have this specification anymore. Okay, I'm not going to have that specification anymore. Okay, so what I'm actually going to have, I'm going to have X, that's a matrix, okay, which follow, okay, now, normal, okay, normal with that, okay, then I'm actually going to have, this is going to be a mean vector, then I'm going to have variance covariance matrix, because I'm now talking about multivariate. So that's a specification of multivariate normal. Okay, so in a multivariate normal, then that very mean is not just going to be just a single mean, it's going to be a vector mean, and that's why you have a mu1, mu2 up to mu p, because the numbers of variables I'm interested in is more than one, and that is why it is called multivariate. Now I have a multivariate data set, then I'm actually going to perform multivariate analysis because it's a multivariate data set. Does that make sense to everyone? Okay, now if you take a look at that, now the specification now is going to be this. I understand my statistics perfectly. I understand my mathematics perfectly because I pay attention to what is behind the scene. I don't just write equation. I don't just write notation, but what is the significance? What is the connection of the notation to reality? The moment I can figure it out, then I understand what I'm doing. Now, please pay attention. all the notation important. What is this guy talking about? XI. When I say XI, I'm talking about blood pressure, weight, height, so many variables I'm interested in. Follow multivariate distribution with a mu. That very mu is going to be a vector mean where we have a mu1, mu2 up to depending on the numbers of variable. Then I'm no longer going to have a variance, but I'm going to have a variance covariance. Because the variance covariance in the diagonal is going to give me the variance of each variable. In the off diagonal, I'm actually going to have opportunity to see the covariance between pairs of variable. Does that make sense? Okay. Now we want to now that you understand that, we want to apply a chronicle now in multivariate setting. Now, if I let my y, take a look at this guy now. I let my y to be equal to a vector of x transpose. Okay. Now, if I have a variable y in a stochastic environment, okay, we normally want to have the average. What is the average? The average here is what we call the expectation. Expectation of y means the average of y because y varies. The blood pressure varies, the height varies, the weight varies. Then I actually want to measure the collective mean of them. That is that. Okay. So if I want to find the expected value of y, then I should be ready to do a chronicle product, okay, between matrix ones and the mu. That is that. That will give you the mean vector. Now, where you get the mean. Okay, whenever mean is involved, variance will be involved. Does that make sense? Whenever mean is involved, variance will be involved. And let me tell you this, the variance of y now, don't forget, my y is a vectorized, is my y are the x1, x2 up to xp. Okay, now if I'm seeking the variance of them, oh my God, then I'm seeking the covariance of them. So the chronicle product is going to be that multiplied by that. Now, the interest is understanding the covariance structure. Then, if you take a look at this, they become important to me. Take a look at this guy now. If you see that now, know that the covariance matrix is block diagonal. What you see in the diagonal represent the covariance. You can see now that we're talking about. Okay. Okay. Now, if that is taken, I'm actually going to move to the next one. Now, in this class, I've given several, I think I've given some example, some assignment questions centered on scatter plots. We all know why scatter plot become necessary. Okay. So if I want to know the relationship, okay, particularly the scatter plot matrix, I want to know the relationship between pairs of variables. Okay, I can do that. Okay, now if you take this is what you normally see. If you take a look at that, that give you a scatter plot between two variables, right? Okay, between the MPG and HP. Okay, but if you take a look at what I have here, and if you want to have access to that, okay, you can actually plot. Okay, look at that. Look at this now. Okay, can plot that and you'll be able to see. Okay, and this, if you load a car, you can actually have access to that. Now, when you take a look at this, okay, you have opportunity, okay, for you to be able to see what I call, in addition to that, you have a bus plot that is giving you a bus plot. Why do I need to put a bus plot? I'm looking for relationship. Why do I need to indicate a bus plot? In addition to that, I also want to have a sense of the distribution. I can use bus plot to understand the distribution of my data. Okay, how? Okay, when you have a bus plot, okay, the bus plots contain 5 number summary, right? Now, if the Q2 is very close to Q3, okay, we actually have a skewness. If Q2 is more closer to Q1, there's going to be a skewness. But if the Q2 is in the middle of Q1 and Q2 and equidistant, we have a normal, and it means it's normally distributed. Okay, so I wanted to take note of that. I think I've explained um that before. Now take a look at this. Two versions of a scatter plot matrix in R. Okay, I've given you assignment on this. This will enable you to see relationship. You can see some have a straight line relationship, some have a kind of curve, and in some they even with the straight line relationship, some have a positive, some have a negative, and so on like that. And if you look at the other one, if you take a look at what I have here, you're actually going to see that in the diagonal, I indicated a density plot. We have so many plots to investigate normality. Okay, box plot, density plot, histogram, stem and leaf plot. There's so many plots that we can actually use in that regard. Okay, because of my time, I'm actually gonna move. I think you are familiar to all of that, and of course, we can also have a two-dimensional, a three-dimensional scatter plot. Okay, here MPG, HP, and WT. Okay, and of course, I put a code for you. Okay, I'm gonna spend more time here. Okay, you know, uh, each map. Okay, you also want to give a correlation, like you want to give a correlation between WT and HP. The darker the color, the more it is strongly correlated. Okay, when the color is so dark and sharp, okay, but it is if it is kind of faint, okay, it means is the correlation value is very close to zero. Does that make sense? Okay, like here now, it's very visible here. Okay, so here we're still talking about correlation plot, okay, where it is dark. Okay, I just wanted to notice that even if you look at the figures, where it is kind of very dark, okay, the correlation is high. When I say correlation high, it could be high negative or high positive. But where it's shown faintly, like if you take a look at this guy, that correlation is very low. If you look at the corresponding correlation value, very low, and look at that, this is not sharp, right? The one that you cannot really see, the correlation is very, very low. Does that make sense? But this guy now, very high. Do you see that now? That's what I mean. You want to look at it in terms of color. Okay? The same thing here. Okay? It's another one, image in heat map. Okay? So when you look at in terms of color here, okay, in terms of color, you can actually see it's indicating some have high correlations and some have low correlation. But let me tell you this, situation where there's so many variables, and you are looking for relationship, okay, this may not be a good idea because of so many variables. You're actually going to have so many colors, and you could be overwhelmed by it. Can somebody remind me if you just read that did for or if you have done 4051, there's a replacement for that. That's an alternative. Can somebody remind me what we can use instead of that? We have so many variables, and you still want to maintain the distance. So what can we use? This of you that did 4051. Situation where there are so many variables, so many variables, this is not going to make any sense. So what are you going to use? Has anybody heard about MDS, multi-dimensional scaling? Yeah. Because you got so many variables, how can I project from high dimensional into a lower dimensional space in such a way that you know the distance in the original high dimensional space will still be retained in the lower dimensional space. That can be achieved using the MDS, multi-dimensional scaling. Okay, so even though this makes sense, but when even with this now, even with how many variables now? One, two, three, four, one, two, three, four, five, six. Okay, we are still struggling to see some numbers, right? We're still struggling. Imagine we have like in gene expression data, there's so many variables. Okay, you could be overwhelmed by that. That would be cumbersome. So, and that's why, research in the world, continues. We're always going to make sure we continue to do research to be able to improve the quality. Okay, we actually want to improve the quality on the quality on modules or quality on activity. You know, we actually want to have a better world. So we can no longer, things are changing, and when things are changing, of course, we should be reflected in the model. We don't want situation where we're going to use a static model for dynamic situation. That doesn't make sense. There must be an agreement. And where we want a kind of technique where we can get our, the information at a glance. Look at that, get the information because of time. We don't want to waste time. And that's why we need to improve on what we do. That's why we need to advance our research. We can't be tired of doing research. Okay? We can't be tired of doing research. Okay, what is next? Now, let me tell you this. It's becoming so complicated. Okay, but let me tell you this. Even oh, the mic. Oh, oh, oh. Thank you. Yeah. Okay, so like I said, um, um, the topic, what we're going to be doing from now, will be complicated. I just want to prepare your mind, mathematically. But let me tell you this. Uh, the moment you follow what I'm going to be doing, I just want you to follow it with practical mind. If you follow what we're going to be doing with practical mind, you are never going to have you will understand what we're doing, even if it's us very serious theoretical structure. Does that make sense? So what I will challenge you to ask me all the time, okay, this particular notation, what does it represent? Okay, I don't just want to do math. I've done math in high school. So what is the essence of this math? Then you care to know the essence of the math. So the moment you understand reason behind the math, then you will appreciate more doing it. Okay, so even though we're going to have an R software, but you need to be able to understand what is programmed in the software you are using. Does that make sense? Is there any question before I go today? Is there any question? Okay, if there's no question, I'm going to say this. I want to believe by now you've been receiving your grade for assignment. And of course, if you feel dissatisfied with, because I told my TA, when you are grading, when you grade somebody, maybe less than 100%, that you must provide post assignment comments. That must be comment. The student deserves to see, okay, what did I get wrong? Stuff like that. And of course, solution, we delay the posting of solution because some students seek extension, okay, which is normal in the first week, because in the first week, student normally they don't settle in well on time. So, and that's why we are actually allowed that. But what is going to be the moment the TA finish grading, immediately now Of course. So probably the following day, the solution will be made public. Does that make sense? Okay, in the absence, and next week, watch out. I'm actually gonna post uh, assignment, sorry, um midterm one practice questions. Of course, I'm gonna dedicate a class, where I'm gonna walk you through the problem. I'm going to tell you, give you a lot of information, what is expected in the exam, whether you're going to bring your laptop, whether you're going to use our software and stuff like that. I'm actually going to let you know about it. Does that make sense? So make sure you check the canvas, keep track on information because we live in a world by information. Make sure you all stay safe and have a lovely weekend. Bye for now, everyone.